Hi, I'm Johannes Bechberger, and we will be talking about Java profiles. Without further ado, I want to start with my presentation. So, who of you developed a web application once in a while because people told to you, hey, aren't you a web developer? Couldn't you write us just a small app? Has that happened to any one of you? Oh, yes, I'm in a group of web developers. That's unusually. Usually I give this talk in front of Java developers and they're like, But okay, yeah, that's happened to me. So it was the Corona times 2 years ago, and I was at a local conference which we organized with a few students, and we want to have some interaction so that we can ask the people in the audience how old, some questions like how old is the universe or so, and have like a small quiz where they can win prizes. And they were like, Johannes, you're a software engineer, you can write software. And I'm like, yes, that's what I've studied for 6 years. That's why I did a master's, to develop web applications for some student groups. So I thought like, yeah, it could be an easy web application. We have a client. I didn't use any fancy frameworks because it was just a simple form. I have an admin, and the admin can set the questions. The client regularly asks the server, hey, do you have any questions? And I thought the server can be simple because we expect like 90 people on the client side, 90 people in the audience. So thought I just store everything back in a JSON file. The file system takes care of all the synchronization, and I'm fine. Because I thought with Donald Knuth, premature optimization is the root of all evil. And then the event came. Any guesses what happened? Any ideas? Did it work? Yes, it didn't work, of course. So you know, when we filmed this at a central location because it was still Corona, but we could record everyone in a central location, and was like in the evening frantically restarting my web server, so it dropped the connection to the client, and it was quite embarrassing. And because this quote from Donald Knuth wasn't the full quote. The full quote is, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in the critical 3%. A good programmer will not be lulled into complacency by such reasoning, but he will be wise to look carefully at the critical code, but only after it had been identified. So the problem is, how do we identify this code? And that's where profilers come in. Yay! That's what my talk is about. So when I talk to people on the street or friends that aren't software engineers, there are a few, about what I'm doing, and I'm telling I'm doing profiles, and they're like, are you someone like Sherlock Holmes, looking into crime scenes? Or here more locally, are you someone like Thorsten Falke in the local Tatort? And I'm like, yes, that's who I am. In this case, I don't deal with dead bodies. I deal with software that's totally broken. And I'm like, why is this software broken? Who's the culprit? Yes, there is Git blame. So in software engineering, we still have the thing. But usually when I'm writing my own software, I'm the person to blame. But I want to know what's actually happened. And that's what I did here. So on the bottom, you see Flamecraft building up. That's one of the main tools that we use for profiling, one of the main visualizations. So you see here that the main method took all the time of our server. And on the top, you see a pseudocode of our server code. And so the main method calls the server loop and does some setup before. But so essentially, the server loop takes all the time of the main loop, so it has a write bar. So the width is related to the runtime compared to the is related to the runtime it took. And so then the server loop, it's quite simple as you would expect. It loops over the request, and when the request is question request, then it calls the handle question request. It's important to note that the admin interface wasn't really important because we have only one admin and 90 clients. And so what does handle question request does? It asks, is there a current question? And if yes, emits the current question. And any guesses what this code did most of the time in these top methods? Any ideas? What was the culprit? You saw before what it did on the server. It's parsing JSON all the time because I'm storing all the data in a JSON file, and that was quite terrible. And so now I see what the culprit was. It was that I wasn't using a proper database. So to quote Mario Fusco, I love FrameGraph. When you do something stupid, it punches you in your face and you cannot unsee it. That's what happened here. We clearly see what the problem is. We can fix the problem now, and after we do this, for example, using a simple SQLite database, it works. The problem is the pandemic is kind of over. The thing is, I did this joke like 2 weeks ago, and it looked like it was over, but maybe it's coming again. But anyways, that's not the point of my talk. The point of my talk is that profiling can really help. So it should belong to your toolbox of interesting techniques that you use to find problems. For example, debugging, testing, and as well profiling to shine light on some of your problems. Who I am to talk to you about profiling and then in a second how to write one yourself. I'm Johannes Bechberger. I sometimes talk about profiles. At least stand in below slides that show the word profiler. I work at Submachine. It's one of the many open source projects at SAP SE from Waldorf. And Submachine is an OpenJDK distribution, so we are the third biggest contributor to the OpenJDK currently, and help bring you so cool features like the new and improved null pointer exceptions. And to me, I'm more specifically developing profile front ends. I'm working on the back ends, and I'm also working on profiles themselves. And with this out of the way, who of you used the profiler before? Oh, that's almost all. It gets more and more target gives. Maybe there's a correlation. But no, so JetBrains also asked the questions, and it was less. So cool crowd here. Selection bias does affect this work probably here. But what is for the non-initiated, what is profiling? To quote the Hexas dictionary, it's essentially to create a profile, and the profile is a report of the amounts of time spent in each routine of a program used to find and tune away the hotspots in it. That's what we're doing. That's what we did essentially before in my example. And there are different profiles. There are two main categories of them, and one are instrumenting profiles. Essentially, we have here a server loop code, and you might wonder how you might think about how you would do it without a profile to see how long the server loop did. So essentially, we'll probably take the time at the beginning, take the time at the end, subtract it, and print it. And that can be automated, and that's essentially what instrumenting profiles do. They do it whenever a class is loaded. But the main problem is like profile code and production code isn't the same because you're changing the code. So it has some problems, and therefore nowadays it's usually not used anymore. What we nowadays use is the sampling profiler, where we essentially regularly ask the JVM, hey, what are you currently executing? And it tells us, okay, I'm executing the method A, calling the method B, calling the method C. And so we get an approximation of our results, because we're only asking it like every 10 to 20 milliseconds. But the cool thing is our profile code and the production code is the same. We can even run the profiling during production to monitor. But profilers aren't rocket science. So I thought, yes, I could write my own. If you want to find out more, I linked to the code, I think, or the blog post with this QR code, but don't worry, at the end they have a QR code with all the lists that gives you a list of literature. So essentially, I thought, yeah, I could write my own, probably 240 lines of Java code, put it on my blog wrote a blog, and yay, people liked it, and some give it talks about it. So essentially, what we want to do, we want to implement a pretty simple profiler, which you shouldn't use in production, but when I gave this talk in Milan in May this year, someone came afterwards to me and said like, at our client, he's working on a consultancy firm. In our client, we can't attach a profiler, but I could use your code because it's open source and directly sneakily copy it into our application and then use it. And I'm like, oh. But no, so hear me out. Everything you put on the internet as open source could be used by anyone. So, ta-da! It's probably somewhere in a Milanese banking application or whatever, baked in. Yay! So essentially, what do we have? We want to attach it at runtime, or before, and we want to attach it to the JVM so it runs concurrently, and then we have main thing that parses the options. Then it calls profile. Profile just takes the sample, so asks the JVM what are you currently executing. Sleeps, sample sleeps, sample sleeps. This turns into a store. This stores this then back into a store. And in the store we then later use this to produce a flame graph using a normal D3 library. But essentially that's all of the profile. So it's 240 lines of Java code if you omit like many things that should be done, because there's also parallelism is hard even in Java. So, but afterwards it was like 300 lines of code. But that's Hacker News might be a weird place to comment, but there were so many people commenting like, "Hey, I found a bug." It was really great. But anyway, so we have a main class, and the idea is how would you implement such an agent? If you've never developed an agent, you probably know the main method. You know this public static main method. There's even, because it's Java, you can even use C notation for the array. And nowadays, I think since JDK 21, you can even use this notation, but that's not what we want, because it's not the entry of like our program. But we pass the agent where minus Java agent and can pass it arguments. And the idea is we can either attach it at the JVM start when our program starts, or later. And there are two different methods for both. So we know whether it's attached at the beginning or whether it's attached later. And what the main method essentially does, it starts our profile on Diamond thread. The idea is it has to run concurrently, because it should run alongside your application and don't disturb it. And so when the application ends, your thread also ends. And then now to the profile. The profile, as I said, samples, sleeps, sample sleeps. And what it essentially does, we create a new profile, and the cool thing with Java, we can add shutdown hooks. So what we do, we tell the runtime, please, when you shut down the whole JVM, run our profile on end. The thing is, we need this to produce a flame graph in the end, because otherwise we wouldn't write down the data. And the profiling, the sampling itself is quite easy, because in Java we can just ask the JVM, give me the stack traces of all threads. And the stack traces is all we want. We just add it to our store, and we look that it's not a daemon, because our profiler thread itself is a daemon. So we want to discard all the daemons, because they are usually helper threads. And so what is part in such a stack trace element, if anyone has seen or used some Java exceptions, essentially the information that you get from a Java exception, like the one-liners of class name, method name, probably the line number. And that's what you all get, and then you store it in a story and turn this into a flame graph. And the idea is, how do we get from samples, so from different traces? For example, in one case, we see that Java apparently executed the main method, which executed the server loop, which executed integration request, and so on, and come back to the flame graph. And this also helps you to understand flame graphs a bit better. So the idea is we have this trace, and then we create, we use a tree data structure, because it's like the data structure computer scientists like, because it's usually quite small. We can compress our data, and it's easy to process. So for every node, we know the method because a node is related to a method, and we also know like how many times this node appeared, how many times the trace that it belongs to appeared. So in the beginning, we have a main method, and we know it appeared once, and the server loop appeared once, and so on. And now we're getting a new trace. It's the same as before. So we're incrementing the number of samples because we saw main before. We know we saw also the server loop as a child before, and so on. Now we're getting to a different trace, and so here we're going till crowd question, but we didn't see post-JSON, so we're not incrementing its value. Here we have a different trace, and so we branch out because we haven't seen this question enabled before, and then post-JSON. And now we can turn it back to Flamecraft. So we know it appeared at maximum in 4 samples. That's main method, server loop, and so on, and can just recursively create the flame graph from this data structure. The advantage here of this data structure is that it throws all time information away and thereby compresses it. It's normally not used in profiles, but it makes creating flame graphs so much easier. So I used it here, and that's quite nice. And then nobody creates such things on their own, but there's a JavaScript library. But in reality, you won't use this, hopefully. Please don't. In reality, people usually use sampling profiles, and there are 2 kinds. The external ones that are developed by people not developing the JVM, and the internal ones mainly developed in the OpenJDK, mainly developed in your JVM, and that are directly present that you can use without downloading anything. So with the external ones, there are ones where you ask the JVM to kindly please give you a stack trace, kindly please tell it sometime when it's ready to give you information that you want, and that's quite helpful because it might sometimes be safer because the JVM only tells you this when it's ready, for example at returns or so. And there's the asynchronous version where you just tell the JVM, please stop anything you do, please give me what you're currently working on, which is slightly more accurate. So the synchronous versions are quite commonly used because they are bundled with, they are implemented in Visual VM and NetBeans, was like in the 2010s where it was quite popular, and then the older people here in the room, that made more sense in the last talk that I gave because there were older people in there. But essentially, for the analyzer by Sun, some of you might have heard of it, was created in 1991, and in 2002 they wanted to add Java support. And they added a library and they added a function. They removed this function 3 months later, so it's not officially supported anymore since like over 20 years, but still people start to use it, and now it's like the popular API that people base their work on. And if you wonder what I'm actually doing, I'm creating a new API that's supported and tested and everything that profilers can use. So that's my day-to-day work. And then there's the built-in versions. So there's the JDK before the Java flight recorder, and that's just a built-in profiler which you can use without downloading everything. The problem was that it wasn't like open source till 2018, so you had to pay money. So many, especially people that started before 2018, didn't even know the existence of JDK mission control because you had to pay like thousands and thousands of euros. So when you're currently using some profiling and monitoring tools, they're usually based on information collected from both async profiler and JDK mission control or JDK flight recorder. But take profiles with a grain of salt, because profiles are just like your software. They could have had more tests. They could break your applications. There are risks involved, and they aren't the silver bullet to find what. They aren't really the silver bullet to find what's going on in your application. They're just a tool, and you choose it. You should use it this way. But after I've told you how you could create your own profiler, you're probably also interested how to use these other profiles. And one profile is the async profile. As I told you before, it's like one of the most commonly used profiles. You can get it from GitHub. It doesn't have support of all platforms. So for example, currently it's not supported on Windows, but the question is, who develops Windows software anymore? On the server space, it's usually Java. It's usually Linux anyway, so most people don't care apparently. So what you do, it's also an agent, but a native agent, so you have to use -agent path and then just give the native library for your platform to tell it to start, and then you tell it, so hey, I want to measure the intervals, so every 10 milliseconds or so, I want it be related to the CPU time. There's wall clock time, which is like the overall time of your system, where every second in the real world is essentially a second in wall clock time. And CPU time is the second related to the number of seconds that your thread that you're currently profiling is actually running. So when a thread sleeps for 20 seconds, this doesn't count for the CPU time. So it depends whether you want essentially have weights in there measured or not. And then you can tell async profile, please output a flame graph that looks similar to what our small profile can produce. And then you pass some arguments. The cool thing is with this, you can also tell it, please output JDK flight recorder files and even run JDK flight recorder alongside, so you get the best of both worlds. And you can even attach it at runtime. And if you want to know more for this, there's async profile, a manual by use cases by Krzysztof Sluzarski. I'll link to it at the end. And then there's JDK Flight Recorder. That's like the official profiling solution for the OpenJDK. Keep in mind, if you've used OpenJ9 before, OpenJ9 has no support for this, so depends on the JVM you're using, what profiling support you have. But essentially, you tell it, please start a flight recording, and then tell it to output its file. And in older versions, you even had to tell it, yes, please enable flight recorder. And you can even start and stop it, which is quite neat, because when you have, for example, a performance outage currently, or when you're experiencing high load, then you can attach it directly when your problem is happening. Another thing here is with JFR that alongside its features like Windows support, it also gives you a lot of information. So if you ever wondered which garbage collection phases your JVM is currently executing, or what the class loader does, or which methods are de-optimized, then JFR is for you. It gives you so much information that I created a website here, submachine.io/JFR events, where you can look all this information up. And see where also the different events are supported. And now back to a thing that's nearer to the rest of the talks here. Consider you're developing your new SaaS business. It's math as a service, so we offer the best Fibonacci numbers out there. It's the freshest Fibonacci numbers, only handcrafted by using the slowest code that ChatGPT could generate for these problems, because we know that it's important that it takes 60 seconds for a small Fibonacci number. So consider we're having this math as a service server, and we want to use, and we want to know a bit more about what our clients are doing. And we want to have more information, especially how long it took to create a single Fibonacci number, in our case, the M Fibonacci number. So we create a session event. In this case, it's a regular JFR event, so we extend with our class session event, the class jdk.jfr.event. And what's quite cool is that we can then use it. So it has a few properties, but essentially we can then use it. We create the event before we're then executing our Fibonacci function, and then we're telling it, hey, please begin, thereby associating the event with a stack trace with a start time, so we know when exactly it happened. And then afterwards, after we emitted the Fibonacci number, we add commit. So we say commit, so please store it back to a file, and then we have the duration too. And the cool thing is you can then use some regular tools like this one that just work on JFR files and view this file. For example, you can see here to compute the 37th Fibonacci number, it took like 67 milliseconds. Yes, it's the best code that ChatGPT could compute. You see also that I'm using Javelin, so you get lots of information and can view it in your favorite tool for these files, which is quite neat because you don't have to look it up into some logs where you printed it to. And there's of course other tools that give you other information. I've shown you that you can inspect the profile, and that's what I'm telling you now about, but because flame graphs are okay, but they can be quite limiting, especially if you're digging deeper. So one of the tools, there's like the standard in the OpenJDK in the Java world, is the JDK mission control. It started out as an internal tool by some engineers, and then later it grew and was released for normal people to use. And with engineers, I mean like Java developers, JDK developers. And so what it does, you can view a file like the file I've shown you before for our math as a service server, and it can tell you a summary. For example, people that know this tool notice that it tells us that like the memory is full, and yes, my Mac was swapping all the time. That didn't probably help for executing and for making the service fast, but essentially it gives you an overview over the performance characteristics and also over the health of your application. And then it gives you flame graphs, because flame graphs are neat. It gives you information on the memory allocation, so you see when memory allocations happened, and even where, and it also gives you information on garbage collection and much more. And it's quite hard to use, so it has a steep learning curve, but if you've learned it, and if you know how to use it, it's quite powerful, because you can use it to filter, to set some specific aspects, to look really deeply into your application. It's based on Eclipse toolkit, so it's not web-based. It just runs on your as every Eclipse application on your system. But you probably see that the UI isn't so pretty, so it's not what you're used to. And especially it doesn't have any IDE integration. And then last year in August, I was like, I want to have something better, and I'm working as an open source engineer at SAP, and I'm like, I can write it my own. I asked my manager, hey, can I write a prototype? And convince enough people, so I started working on it. So there's my JFR plugin for IntelliJ. It's still a prototype, but you can download it from the marketplace of JetBrains. And what's neat is you can right-click on your method and then just tell it, hey, please run it with JFR, with async profiler, and then you get some information. For example, below you see the tree that we before used to create flame graphs. You can also output just a tree. You see some information on the CPU usage, on the memory usage. You can even like zoom in it and select different time slots. And then you can click on the method and it directly shows you, oh, that's the code of the method, and for every line, how many times it was hit. So how many times did the JVM execute it when I was sampling. Important here is to note that samples and timing doesn't really translate so good, because the thing is we're usually not sampling all threads. So if a thread is hit in like 10 samples, we don't know whether it's with 10 milliseconds sampling interval, we don't know really how much it actually executed. It's just an approximation. And you can have flame graphs in my application, and even more, you can even view events. But I didn't write it on my own, so it was too much effort. I'm not a React guru. I learned React due to this project. It's actually based on the Firefox profiler from the Mozilla people. I worked with them like for 4 months, and now it's a product that you can try out. It's open source. I think it's MIT is licensed. If you have any questions or want to contribute, come to me after my talk, or write me a mail. I'm happy for anyone trying to use it, because it's more modern, and yeah, I hope it helps people. So after we saw it, it's probably important to see the impact on performance. What I didn't have here is the performance impact of the small Java-based profiler, because you see it that like the profiling performance depends, the profiling impact depends on like the settings, but it's usually like low 2 to 5%. But the thing is, our self-written profiler isn't that bad. It's on par with async profiler. Of course, it does have less features, but it's quite good performance-wise. You could actually use it. I wouldn't recommend it because it might contain bugs, but yeah. So profiling usually has an overhead, and especially keep in mind that the file sizes generated by these tools can be quite large. So test it beforehand on your server application, in demo environment. What people usually ask me then after my talk is like, but what about continuous profiling? They use tools like code.talks or Dynatrace, and there aren't exactly these tools in the open source world because there's a lot of effort to implement, but there are the tools with which you can continuously profile your application. That's typically helpful when, for example, you notice that your lunch service application crashed or had performance problems every time, like at 1 p.m. on Mondays, because everyone wanted to see what's in your canteen. And so you can do continuous profiling to notice before to get information on these accidents. So what you can of course do is just tell async profile, hey, please create a file every 1 minute. Every minute, so it creates a new file, and you have lots of files with like a timestamp. But this is quite cumbersome because you have to deal with getting it out of the server on your own. So nowadays people use tools like Periscope, where you can have like nice flame graphs. They are auto updated using async profile under the hood. So actually actually the async profiler that you can use on the command line, they just wrap it in some Java code. And of course, there are many, many more tools out there, for example, Jaeger or Parker, and many more also commercial tools. But I'm slightly out of time. Therefore, what I want you to take with you is that profiling is really helpful. You should put it in your toolbox of techniques before something happens where you need profiling. So it's not too hard to download these open source tools. They are for free. If you find a bug, please report them or fix it yourself if you want. Just take a look at the tools, try them out. If you're not working with Java, there are of course tools for other runtimes. For example, Periscope works also on a few other runtimes and supports them. So yeah, take a look, and I hope it can shine light on your problems when the next time your customer comes and it's slow. When you want to learn more about this, I'm part-time nerd on Twitter, where I tweet about profiling related stuff, and I also write profiling related blog posts almost every 2 weeks. You find my team at Sweet Submachine or submachine.io. If you want to know more about any of the literature, please go to this QR code. This is also where you can give me like direct feedback, which I would appreciate. So that's all. I think we have some time for questions.